Hello! Today's video is how do we solve exponential equations. Alright, the very first way that we're going to do is solve by equating exponents. So the rule is if b to the x equals b to the y, well then these exponents must be equal to each other. A real quick example of that would be if we had 7 to the 2x plus 1 equal to 7 to the 3x minus 2. Well, because these are both base 7, then I know that these exponents must be equal to each other. 2x plus 1 equals 3x minus 2. And from here I can just go about my normal solving. And I would get x equals 3. But the question is, what if the bases weren't the same? Well, in that case we'll have to make them the same. So let's try that. Here we have 9 to the 2x equals 27 to the x minus 1. And we have to think in terms of powers. Like 9 to some power does not equal 27. Right? But these both could be represented as powers of 3. So I'm going to replace this 9 with 3 squared, and it's still being raised to the 2x, equals 27 is 3 cubed to the x minus 1. Now, power to a power, we multiply the exponents. 3 to the 4x equals... Now here's where you need to be careful and remember that you have to distribute. Okay, so this is 3 to the 3x minus 3. So now we have 4x is equal to 3x minus 3 since the bases are the same, and x equals negative 3. Alright, in the next example, 4 to the x and 1/2 to the x minus 3, I'm going to represent these as powers of 2. So this would be 2 squared to the x equals 1/2 is just 2 to the negative 1 to the x minus 3. And I'm going to distribute that negative 1 here. So this is 2 to the 2x is equal to 2 to the negative x plus 3. So now that the bases are the same, set the exponents equal to each other. We have 2x is equal to negative x plus 3. So 3x is equal to 3 and x equals 1. Alright, and that's how we solve by equating exponents. Alright, so this next topic where we only have one exponent, there's a lot of different ways people teach this, but this is what I've found to be the easiest way. So the very first part is we're going to isolate the exponential. We're going to isolate 4 to the x. And we do that by just adding 2 to both sides. So 4 to the x equals 3. Next, we're going to rewrite as a log or a natural log. We'll use natural log whenever we have e. So if I want to rewrite this as a log, this would be log base 4 of 3 is equal to x. Now I can just solve by using change of base. Change of base tells me that log of 3 over the log of 4 will equal x. And finally I plug that into the calculator and I would get x equals 0.792. Now if you're going to use the book, I think it's a good idea to just show you how our book solves this problem. The very first step is the same. They would isolate the exponent, and then they would take the log of both sides. And the way that they would do this is just to introduce this log base 4 on both sides equals the log base 4 of 3. And now we see that this is actually the same thing. See how we ended up with log base 4 of 3 equals x? Log base 4 of 4 to the x, that's just x equals log base 4 of 3, and then we end up at the same spot, right? We would use change of base and end up here again. But this way is the way I found to be the easiest. Alright, so let's try it. Here we have 150e to the 0.5x equals 340. Very first thing I want to do is get this e to the 0.5x by itself. So I'm going to divide both sides by 150. Alright, so now we would have e to the 0.5x is equal to about 2.26. Now I'm going to rewrite this as a log. Log. The base of the log is the base of the exponent, base e. Go around the equal sign of 2.26 is equal to 0.5x. Well, log base e, that's just the natural log of 2.26 is equal to 0.5x. And this we can evaluate with our calculator. We just type in natural log of 2.26. So just dividing both sides by 0.5 will let us solve, and we get x is equal to about 16.307. All right, for this last example, why don't you go ahead and try this and pause the video. We'll come back and see if you got all the steps right. All right, so you should have isolated the variable or the exponent here. Then you would have rewritten it as a log, so log base 4 of 14 equals x plus 2. Use change of base, go ahead and subtract the 2. Boom. X equals negative 0.096. We just solved some exponential equations. All right, goodbye.